Well, hi, thanks for joining me in my shop here. Hey, I'm going to be taking a look at this really neat, really old radio. This is one of the oldest radios I've ever looked at. And I got this at a yard sale 6 months ago in the summer. And I really don't know anything about it. And I'm not that familiar with radios of this age. These are out of the 20s, early 20s perhaps. And they're really very different than the modern era radio, which kind of started in the 30s, I guess you could say, but all through the 20s. Radios that look very much like this were built. So you can see it's just a box, very simple box. Got a hinged top on it. It's in pretty good condition, if it's as old as I think it is, and I'm pretty sure it is. Then this box has been hanging around for, it's getting on towards 100 years. If you look at it closely, you can see it's got a bunch of very curious holes in it. They seem to be in a pattern for some reason. They're there. Probably something that was going on. This one's got a hole here, or a mark anyway. There's holes here. And if you want to see holes, just look at this front panel here. There's these. It's pretty curious. There's nothing here. I can picture some kind of a control that would be hitting contacts that were positioned in here. I can imagine that, but it's not here. So we've got a number of terminals on it. We've got these terminals here, and they are marked B+, B-, A-, A+. So you need an A battery and a B battery. A B battery gives you voltage to run the plate of a tube, so that's a hint as to what's inside. And likewise, the A battery provided the current to run the heater on the tube. So some terminals here, they aren't marked. There's two terminals here. This one's marked antenna. So we certainly assume that would be the ground. Just get up a little closer here. I think that's a little curious. Well, I'll show you what's inside in a moment, but this wire is a little curious. What's it doing out here? The pattern of these holes is pretty bizarre too. There's a bit of a hole peeking out there. So there's these three big adjustment knobs. I was kind of floored when I saw what this one's actually operating. And then there's this one. This one's pretty stiff to turn. I'm turning these because I know what's going on inside the radio. If I have looked. So I wouldn't turn these without having known what was going on. Wouldn't want to damage anything. So mysterious holes. Yeah, this radio's had a few lives. That would be my guess. So perhaps it's not as old as we think. Maybe the box is older. So I think looking inside, of course, is the way to find that out. So let's do that. So let me just hang on 1 second. There we go. Okay, so let's just take a look down the way here. Okay, so there's not too many parts. That's a big difference from the Sony 2001 that's been driving me nuts lately, where there's a million parts. So let's just take a look at what these parts are. Okay, so down here is the back side of some clips. The place to make connections. So that's down here. Here's a really wonderful variable capacitor. There it is turning. Wow, what a sound, eh? The plates look like they're really too close here. Let's see if we can get a nice view on the camera. I suspect there's some rubbing going on. Oh. It's been like a thrill ride. Hey, too bad I can't do 3D. Wouldn't that knock you out of your seat? Yeah. Look, we're having fun with the radio already. There's something a little curious down here. Let's see. Wow, this camera's great because I can't get my head in there like this. So it's a fan stock connector with a wire. And where's the wire go? Oh, just it's up here to this terminal, so I'm not going to worry about the wiring right now. Let's just worry about the major components. So this is obviously a variable capacitor of some fantastic construction. Well, see, this is an insulator here, and you can see how it's riveted using, looks like brass. It's riveted to this metal solid structure, and then this insulated piece then becomes a support via the screw for the top piece of the capacitor, thereby insulating the stator plates, I guess you would call them, or stator plates, whatever you want, the plates that don't go anywhere. And meanwhile the other one is on a shaft. It actually feels really very appropriate to turn. It's got like a very appropriate tension to it. It allows for very small movements. If it also is loose and floppy, then tuning this thing precisely would be difficult. But because it's see, I can very easily turn at that speed, very easily. So actually, if that's what they intended, it's still working exactly as it was. Hey, you know, there's two of those connectors down there, isn't there? So one is just obviously right on the frame, and the other one, for sure, will be connected to the non-moving plates, the fixed plates. So now there's something really quite curious down in here, and that's this this curious coil. And now we see what this piece of wire is. We send it over here. See, that's nothing more than a way of bracing this coil. The wire had no purpose in the radio itself. This coil is pretty interesting, isn't it? Hey, you see how it's woven. It's woven along. Now that's look right down in like that. So this is no accident, of course. This is done very much on purpose, and it has to do with reducing the I think it's the skin effect, which I believe acts to increase the resistance of the wire beyond what you would think for the amount of copper in it. So the whole trick is kind of like this. It's kind of like this. You have the two wires traveling parallel, like my fingers are. Then they can affect each other over that distance. So a lot of effect because they're traveling along in parallel. But if you can get them to do this kind of thing, so they're only occasionally are they near each other, and when they're near each other, they're not in parallel. When they're in parallel, they're far apart. Boy, this is a terrible demonstration. So I'm going to have to try this again a little bit. Okay, so here we go. So if you wind them like that coil, when they are close to each other, they are crossing, so their effect is minimal. And when they are in parallel, they're far apart. And this is kind of the scheme of this. Yeah, it's very interesting looking because you see the coil, it's very flat. You wonder, well, how could you get this flatness? You can see that they sort of skip every other. This wire actually goes two over before it crosses over. And that's a terrible explanation, but we won't dwell on it. So, old radios had a lot of coils wound like this. New radios, you can still find them wound in special ways, with basically to achieve the same thing I just showed you. Now, enough of that coil. The coil is sitting around. It's sitting around this basically variable resistor here. You can see the slider on it. Just turning the dial on the front here. Let's see what. That also appears to be in very, very good shape. Feels exactly what it should feel like. Windings are all in place, or the turns are all in place. It's a little dirty, but now with this variable resistor, normally it's in a radio like this, it's controlling the current flow into the heater of the tube. Yes, there's a tube here. We'll be looking at that in a second. So that appears to be in good shape, and it's got wires connected to it. This coil, by the way, is connected up here and there. Yeah, let's take a look at the tube. Okay, the tube is in a classic socket there, 4 connectors on it down there, these tube connectors. It's pretty tempting, isn't it, to remove it, because I can see how it's in here. I'm not going to remove it. Let's see what we can read on it here. Well, Westinghouse radio. Westinghouse Radiotron, I believe is what it says. Does that say there V? Does that say 19? Date. Yeah, I gotta pull this out. I have to pull it out. There's nothing to that. Now, I think this tube has been, I guess it's like an adapter at the bottom of the tube here. Marco, can you read that? Okay, hold on. Let's take care of this annoying autofocus. Okay. Oh, it's not okay. There we go. Westinghouse radiotrons. Sold by V19. Date. I don't think there's a thing written there. And at the bottom it says, warning, positively no adjustment if this label is removed. What? Or if dealer's name and date of sale is omitted. Well, that sounds pretty original. Actually slap a paper sticker onto a tube. Positively no adjustment. So I think what they're saying is, don't bring this tube back and expect to get a break on the replacement, claiming that it only lasted a month and a half. You want to make that claim? You better come with some evidence of it. Got it? Because we're sick and tired of people bringing our tubes back to us and claiming they didn't work. And what a mess we got into until we figured this whole thing out. We've just been slapping these labels on the tubes now because we don't know what else to do, really. But that's what we started doing at Westinghouse back in 1923. That's my story. So what is this tube? This is a... what? It's harder to see in the camera than my eyeball. I think it only says Westinghouse. Oh my gosh, I don't see a dimple in the glass right there. Right there. And the glass here is not funny shapes in the glass, so hand blown, I'm sure. Yeah, there's another defect in the glass right there. Yeah, you can see in right through here. Well, you can see air bubbles in the glass too. Wow, it must have been tricky to come up with a glass bulb that was airtight. That's why these things, that's one of the reasons why these things would be so unreliable. Look at that. What's going on in there? It's like some kind of gigantic insect or something. That's really neat. Let's see if I can do a little better job of this. This is kind of neat. There, I can see the yeah, you can see the coil. Like I guess that would be the grid coil. That would be the heating element, the heater right there at the very top. That topmost arm coming over. That's holding the element in the grid, center of the grid. The grid appears to be held only on one side. Mostly today you'd see two vertical posts. You can see the item holding the strut holding the post that's holding the windings, or the coil, whatever you want to call it. And you can see it's in some kind of a plastic material. All this on a tube. You can see the tube has been a flat piece of steel rolled over and the flat edge is probably welded somewhere in there. Hidden away in this glass protector, isolated from the world. Actually in its own world, because there'd be some kind of gases inside here, and also some gases would evolve, especially see that plastic-like material there. Some of that's going to vaporize. There'd be some particles in there, or particles, I guess literally atoms floating around. Very cool, indeed. This is coming apart very easily. WD11. That's what the tube is. Radiotron patented WD11. And then this is, I'm sorry, I'm sure where I'm seeing that right here. So this is I think this is a pretty valuable tube. And let me put the tube down safely. I'll put it right back in the radio. So here's an adapter. WD2 by the Mar company. Adapter. You can practically see that somebody hand hammered those letters into there. Because there's a little bit of lack of consistency. The A in adapters wasn't struck fully. Kind of a spooky notion, but people's fingerprints would be on these things from back when they were done. That's a screw, but that's not. That's a rivet of a sort. Screw. Look, these things have been taken apart. It's been worked on. It's pretty cammed out. Look at that thing. Why would you work on this so much? Wait a minute, didn't I see? Oh, there's two there. Could be screws going into a threaded shaft and just under here. I don't know what it is. There's this pin. What's that pin set? It looks like it's just set in there. I really get a kick out of looking at these things really closely. I'll put it back together. Put it back in the radio where it's been safely housed for, see it's rolling around on top of my, top of here, on top of my. So that's what the socket looks like. And each one of those comes out and goes straight to a terminal. So this key means you can only put it in one way. Because without the key, you could put this in four ways. Four ways? Four ways. I could probably find a way to put it in 5 ways. Okay, next on our list of interesting things to check out is this guy here. Now, one of the things that should make it really interesting is look at this. Look at this. Is not a big thing, right? Sorry, it's out of focus, but it's about the size of a Canadian dollar coin. A little bigger, just a little bigger. It's not very big, but look at how fancy it is. They stuck their name on there. Patent something or other. Wow. A patent on it. What is this that could be so great? Ridley resistor capacitor combination. Right there. Now, you know, in today's world, a capacitor is no big deal. But back in 1920, in the 1920s, building a capacitor was, you know, leading high-tech work. Required exacting standards to get any kind of consistent result that you could sell. And one of the applications of a capacitor is this thing here, this arrangement here. You have a capacitor, and this right above it is a resistor. This doesn't look like it's marked. This will be a mega ohm or 5 mega ohms or something like that. It's knurled on the ends. Because there's an expectation that somebody's going to grab it with their fingers and pull it out, just like I'm doing now. It's very much like a modern day fuse. In fact, you could easily mistake this for a fuse. If you put a fuse in there, this radio will never work. Well, this is a resistor. This one's, well, we have to measure it, but it should be somewhere around, 5 mega ohms. It could be as low as 100K. It can range. And this and the capacitor work together to manage to detect the audio signal that's in the RF that the radio is receiving. It's got another fan stock connector. Pretty flaky wiring system in here, right? Like, why wouldn't you just put that under a nut? Well, the only answer is because you plan to change this a lot. The same thing with a resistor. I mean, it's designed to be popped out and another one popped in, so you could quickly try different sizes of resistor, see which one's working for you. And I give one last part to really take a close look at here. This is something I'd never seen before until I saw this. Let me just change the focus a little bit here, folks. There we go. Oops. That'll do the trick. Okay, so look at this. This very strange looking thing. I'm talking about this. Let's see what it says on it here. I think that's like. Now you know what? I got to change the focus again. It does say Crosley, Cincinnati, Type D condenser, patent pending. Type D. That's as far as they'd gotten in the alphabet? Type D? Wow. Yeah. Well, I don't think it means that exactly. Now take a look at this wheel here. And I'm going to move the dial out front. See, that's what the dial out front. The dial out front is moving this wheel. See the spring? The spring is pulling that metal. There's another spring there. Because a balanced pull, obviously, of this piece here against this. Oh, you can see it moving. What is going on here? Here it is. Got it from above. And let me just change the focus again, just a little bit. I will now turn the dial. So, wow, this is the most clumsy thing I've ever seen as a capacitor. This is unbelievable. It's just two plates, and you separate them by turning the dial. I really wouldn't have thought you could even do this until I saw it. But I mean, it makes sense as soon as you see it. Yeah, that's an interesting, clever way, I guess. Trying to see how it's hinged down here. It might just be sitting in there. That seems to be held on. Look how you make a connection to it. It's that big piece of... I'm not sure what that is. You know what? Maybe this is a piece of non-conductive material. That's just certainly what it looks like. It's probably a metal plate. I think I can even see a thin plate there. Yeah. Wait a minute. In the camera's own shadow there. Yeah, there's a thin plate there. Probably more on the other side, of course. Can't quite see it. And so that bolt must go through, probably soldered or connected somehow to the back of a plate. There's one on the other side. Here's the other one. Once again, fan stock connector. Well, those are the main pieces of the radio. Just run over them really quickly. Capacitor, grid link, resistor, and capacitor. Variable capacitor. A vacuum tube, triode vacuum tube. A rheostat. A really cool coil. So, apologize for the lack of focus. I can't look at two things at once. Not too often, anyway. So that's it. That's the radio. Wow, what are the chances I can make this thing work? Well, I'll tell you, there is something interesting I noticed. Maybe you noticed it too. I'm just going to put the autofocus back on here. Oh my gosh. I am there. I am just mouse. Well, you can't see what's going on here, but I guarantee you would have been laughing if you saw that. So, but I think what I noticed is, hey, everything's hooked up. There's wires going everywhere. I don't think there's any terminals that aren't connected to something. For all I know, this is exactly the way it's supposed to be wired. Then all I got to do is just put a little voltage on these terminals. This baby might work. This tube might be good. But I certainly wouldn't jump to doing that, because I don't know enough about these radios. And I have another one. I'm going to show you the other one next. I have another one. So, and you know what? I wish I knew the make. If anybody can give me any hint. I think it's home built out of parts. I think somebody grabbed the box, grabbed the parts, took them out of some other radio, cobbled it all together like this. I don't think this came out of a manufacturer like this. Don't think so. Anyway, well, thanks a lot for watching the checkout. This is the very thorough checkout, and see you on the next video.